This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Can you please try logging the computer because mine is not taking.
So use my account?
Yeah, I think due to some reason I will sign out once I finish the lecture.
I'm not sure whether we are allowed to log in. I don't. Okay, it seems like. No, that's not possible. Should I? Oh, student. Do I have to do that? That's my username.
No, I'll sign off and then I will log in again. Yeah.
I have a question about components. So I didn't actually get.
Today, would you please go and collect it at any?
They were finished.
No. We got the more one. More. Oh, yeah. Okay. Some problem with the PC. Please again. Yeah, I tried to switch it off and still there is a problem. Student, I think, slash. Good. Seems it's not. They should be fine. Yep. Good afternoon. So your PCBs will arrive tomorrow. So we got the notification finally. So then what we will do is, we don't know tomorrow at what time, in the afternoon or in the morning, I'm not sure. It's depending upon the delivery time. As you know, it got delayed because of the national day in China. Unfortunately, you know, our PCB fabrication falling during that time because of the semester break. So then what we will be doing is, if you are on the Mondays and Tuesday session, please collect your PCB on Wednesday or Thursday as per your convenience. And another announcement is, as you know, you have to finish your project by short work. But if I say that some of you might decide not solder or half solder or solder without understanding, because of that I am going to give you three options. So option number one, if you are going to travel soon after the first exam, you may have to finish it by short work. If you are not going to travel soon after your first exam, we will be running sessions in the first week or second week of the exam. During that time, we will find out when you got a gap, and then you can come and by the time you can finish and you can work on your DSO. Then if you don't have time at all, we are going to have a session, 1 or 2 sessions after the final exam, week 3. And but then that sessions are only useful to students who are staying back. Like if you are planning to travel overseas, you may consider finishing by short work. We will give you required support, or during the exam period we will have some sessions. So then you can make use of those sessions. But if those 2 sessions are not good, and if you are not traveling overseas soon, then we will be having 1 or 2 sessions after the exam, depending upon how many students are left. If more students are left, we will have 2 sessions. If only a few number of students are left, we will have only 1 session. After the final exam, week 3, maybe we will give you 1 day break. If your final exam finishes on Wednesday, we will have maybe on Friday, so that you are getting 1 more day for soldering. So these are the options we are giving you. Means once you take this subject, as I said, you don't have an escape. You have to understand DSO. So that's the reason I am giving you more time. So then you got pretty much flexibility. Even with the lab, these labs are just for soldering and asking questions, so that you don't have to follow the fixed, your timetable. some sessions you can come, you can leave, and then you can go to some other sessions, because all about soldering. If you are soldering from home or soldering after some time, not in the lab duration, everything is acceptable. You have to demonstrate your DSO is working, and for that, whatever the support you are required, we will be providing. So I will post it on LMS. All these things, yep.
How about the report and the final presentation?
Yes, so the final presentation and report, we don't have a fixed report, like a report writing, or not like a PowerPoint presentation. So the report and the presentation, what we meant is you will be bringing your DSO and then show to the tutor. The tutor will ask you, you have to show that, okay, this waveform is coming, this waveform is coming, the DSO is displaying the waveform. So that is a first tick. So your DSO is working. Then, so that is a real presentation. Then your tutor might ask you a couple of questions, like what is a trigger, for example. Maybe we will not ask this question because I already told you. And what this amplifier will do. Then you can't say that, oh, actually we don't need this amplifier, it was a mistake. Or some innovation that you introduced, what is that innovation? So a couple of questions and then you answer, that is the presentation. So that you can do soon after you finish, it will take like 5 minutes. They will ask, that is a presentation. So you don't have to formally give a presentation. So you have to present means you have to show the board, and if your board is only half working, you have to show half working. Then you also have to explain why it is not working, half part. So better make your DSO working, that is easy to explain. Rather than your board is half working, you have to do a lot of work, and because the reason should be correct. So that's the reason, carefully solder it. You are getting 2 boards. We are giving you plenty of time. So we want to make sure that everybody understands the system level concepts, because that is the whole point in learning this subject. So all these things I will put it on LMS, so that you can plan your studies, or you can plan your DSO, the project accordingly. So in the last lecture we discussed about the voltage regulator, because voltage regulator is an important part in a system. These days you might not make a voltage regulator. Actually, you will be buying a voltage regulator. Until and unless there is a specific requirement, then you may not buy, you may design one voltage regulator. Then why we are learning then voltage regulator? The voltage regulator we are learning. Why? Because that got a feedback loop. So in the electronic system, you should know how to incorporate a feedback loop. So that's the reason we are teaching you the voltage regulator in detail. Another aspect you have to learn is how we can step up the voltage. Because stepping down is always easy. If your input is equal to 5 volt, you want a 2 volt, it is easy. But when it is 5 volt, how can you step up to 20? So that also you should be having as a system engineer, how we can step it up. So that's the reason we are learning the voltage regulators in circuit level. 2 reasons. One is you should be knowing how to incorporate a feedback in your electronic design. So that's the one point. Second point is you should know how to step up and step down the voltages in a circuit. So as I discussed in the last lecture, the series regulator. In the series regulator, if you recall, what we have got is we got a transistor in series, and then we are getting like this, and then you got an op amp. So op amp is connected here, then you are going to have a feedback loop, see, feedback loop, and then this is your output. So this is positive, this is negative, and then it is connecting here, and then you got a Zener diode. So this is your V input. So in this circuit, this is a simple feedback circuit. So if you got a V in, and then you got output, then using this feedback loop, actually we are controlling the voltage. If the voltage is going up, it will make it sure that the output is a constant. For example, if you want, here it is, say this is 10 volt. So your input is 10 volt. Then the requirement is you may need a 5 volt here. So you are going to make a design. So when you need a 5 volt here, then you will be getting one transistor, and then you will be getting one operation amplifier. But then when you need here 5 volt, the Zener diode is very important, because Zener is going to give a reference voltage, this X voltage here. That X voltage will, if this is X voltage, it will make sure that this is X voltage. So this is X voltage. And then if you are using say 10K is maybe more. So I am going to put 1K here, I am going to put 1K here. So then what is the Zener voltage here you will be buying in order to get 5 volt? So definitely it should be 2.5 volt. So if it is 2.5 volt, because of the negative feedback, this will be 2.5 here, because these resistances are equal, and then this should be 5 volt. So that's how we are designing. So that's how then you should be able to explain how the feedback works. So how feedback works is the 10 is not going to jump into 11 volt. 10 might be fluctuating in real case, maybe very small, 10.01 or 10.1 or 9.999. So very small fluctuation. But then we don't want that fluctuation coming here. In order to explain properly, I am going to exaggerate the variation. So it doesn't mean that this much fluctuation will happen in any power supply, unless you design one now without understanding about the power supply. So all the good power supplies, it will have very good voltage regulation. So if 10 voltage is going to 11 voltage, means your output should definitely immediately will increase from 5 volt to more than 5 volt. Then what will happen is your 2.5 volt will increase, because the voltage output increased, so this voltage will increase. When this voltage will increase, what will happen is op amp output, this is error voltage, ER. So this error voltage, what is that one? Gain into A0, V positive minus V negative. So that's what error voltage. So error voltage, this negative is going to increase. When this negative is going to increase, means what will happen? Error voltage will decrease or increase. When this is becoming more negative, error voltage will increase or decrease, because definitely it should decrease. When it is decreasing, means here you are getting, either you can think of voltage or current. So current will decrease or voltage will decrease here. So when this is decreasing, what will happen? Your output should decrease, and then so that it will come back to 5 volt. Then when this is decreasing to 9 volt, again same thing will happen. The output voltage will become less than 5 volt. So this will become 2.5 will become less than 2.5 volt, and then what will happen is V negative is going to be decreasing. When this is decreasing, your error voltage will increase, and then this output again will increase to 5 volt. So that's how it is working. Then now you know how the feedback is working, how it is making it constant, because this is a very important concept. This feedback you might be using in different places when you are designing a system. Now the question was, suppose somebody is shorting here by mistake, then what will happen is your current is going to, lots of current is going to come here, because you are shorting the emitter. So this is a question I asked you. So obviously thanks for those of you emailed me your answer. So my question is, when I am shorting the emitter, why current will increase? Sorry? Yep. So because your base emitter voltage, previously you may have some voltage here, and then now what is happening is when you are shorting, your base emitter voltage will decrease and more current can flow, and then it can damage your transistor. So then we came up with the idea, we may put a protective circuit. So protective circuit means current protection. So you will be putting a resistor here, and then your aim is you are going to limit the current to maybe 0.7 amps. So you don't want more than 0.7 amps flowing. In that case, what you need is you will be putting a 1 ohm resistance here, and then from here, so I am connecting from here, you are going to connect another transistor base, and then the collector is connected to here, and then emitter you are connecting here. So there is an emitter. So when you do what will happen is when you are getting, so your maximum limit is 0.7 amps. So usually the current will be less than 0.7 amps in order to get to 5 volt. Suppose by mistake you are shorting to ground, or you connected a low impedance path to ground, maybe few ohms. Then what will happen is it can draw lots of current. Then this transistor can heat up and damage. So in order to avoid that one, if you got this one 0.6 amps, no problem here, because then this transistor is not on. When it becomes 0.7 amps, then this voltage will become 0.7 volt. When it becomes 0.7 volt, what will happen is this transistor will be on, and then this is going to be collector current, that is beta times IB. A big current will be flowing from here through this transistor, and it will come here. So that will be, I don't know, maybe couple of 5 milliamps, depending upon how much beta you are going to use, how much base current this transistor is drawing. I am just taking maybe 5 milliamps. So then this is drawing 5 milliamps is coming, and then this 5 milliamps is coming here. And then what is happening is there are two possibilities. When it is happening like this, you are taking away lots of current from here, the base current. Because base current is very small, then this collector current is big current, beta times IB. So that will happen is that will limit this current, so that you don't get 0.7 amps flowing. You know what I meant? Or it will stay, depending upon how you choose this transistor, maybe 0.7 amps will stay there. Another possibility is if you are drawing too much current, this transistor is drawing too much current, what will happen? You don't get much current for this one, so that this will be off. That also is another possibility. And then what will happen is your this 5 milliamps will come here, and then it will come through the ground, and then it will go to the output. So it's only a little bit current. It is not going to affect your system. So that's how a current limiter we are using. So now you understood the current limiter. So the current limiter will limit the current, because you are taking away a chunk of current using this transistor, the collector current. And then whether it will be off, whether this transistor is off or keep at 0.7 milliamps, depending upon how much base current is required for this one or how much current is required for this one. So you can, by tuning that one, by choosing accordingly, you can make it operate in either way. So that this will make sure that your current is current will not exceed 0.7 amps, that will not come into the output. So that's how we, now you know how to incorporate so the whole point is not just learning the voltage regulator. Now you know the feedback, how the feedback concepts work, so that you can implement. Now you know if you want to limit the current, then you know how to put a limiting resistor. This resistor is a limiting resistor transistor. The scheme, this scheme is used in LM741. In the operation amplifier output, they have used this one. So we came up to there. Then we said this is called a series. So this is a series regulator. We have got again parallel regulator. Series means your transistor is a series, and now we got a parallel one. In the parallel one, your transistor is going to be in parallel. So this is called a series regulator. So we came up to the parallel regulator. So first one is a series regulator. So first one is a series. So again, series regulator is a step down. So I must say that step down means your output voltage is less than input voltage. Again, we are going to study parallel or shunt regulator. So again, parallel or shunt regulator also is a step down, because it is stepping down the voltage. Then we will study another one called switching mode. Switching mode regulators. So this could be stepping down, step up, bar down. So you can do both the ways. So these are the three major classifications. So now we understood this one. Then once you understood this one, it is easy to understand this parallel. Then we will go to the switching mode. Switching mode, the working is slightly different, but the feedback is same. So the feedback part you already understood for switching mode as well. So now we will start the parallel one. So I will connect it. So I will draw it because some corruption on my file, so that's fine. So the shunt. So the second one is a parallel or shunt regulator. So we already studied the series one. So the shunt one better to design. So in the shunt regulator, the difference is this is a series. Series means your transistor is in series. In the shunt one, the transistor will be in parallel. So then in the shunt regulator, again in the same design, something like this, then you got a resistor, then you will be having a Zener diode, same way as the series one. Then you are having a resistor here, and then that is your output. But then here the difference is this is your op amp, and then here you are going to connect the reference. You got that transistor something like this. So from here you are getting the feedback loop, and then this is also going to be ground. So this is your V in. So that this is a shunt regulator. Or parallel regulator. So the difference is now the transistor is in parallel, and so shunt regulator also step down. Suppose this is equal to 10 volt, then what you can get output is maybe less than 10 volt. And the same way we can design the shunt regulator. You can choose your Zener diode, the Zener diode, and R1. So this is R3, R4, and then maybe this is your R2. So same way by selecting the Zener diode and R3 and R4, you can decide what is output required. The working principle is again pretty much same, because you are using the feedback, but then this time your transistor is connected in parallel. Suppose your 10 volt is increasing to 11 volt. So if your 10 volt is increasing to 11 volt, what will happen? When this voltage is increasing, definitely the current through this R1 will increase, and then this voltage also will increase, and then what will happen? Then the current will increase, and that current will be, so the voltage will increase here, because this is going to 10 volt, because here you are going to connect a load. So that is your load, maybe whatever the load you are connecting, or this could be a part of your PCB, you are powering so many ICs, and then that is your load. Then when this voltage is increasing to 11, this voltage will increase from 5 volt to up. When this voltage is increasing, what will happen? This voltage will increase. When this voltage is increasing, what will happen? What will happen to the error voltage? Error voltage will increase. When error voltage is increasing, what will happen? This collector current will increase. So that this here, when your voltage is increasing, and then your current also will increase, because that's the reason your voltage here is more, because your RL more current is coming. Then when this transistor is drawing more current from this line, then what will happen? This output voltage will decrease. So that's how it is working. Same way, when the voltage is decreasing to 9 volt, what will happen is then this current is going to be decreasing, and then what will happen is this voltage is going to be decreasing. So this voltage will decrease. When this voltage is decreasing, then your less current will be, error voltage will be less. So less current, so that this is not drawing much current, this transistor, so that you are getting more current here. So here you are using this transistor kind of a valve. You are adjusting the valve and then keeping the current, and then you are getting the regulation. So that's how it's called a step down. It's called a step down. Why? Because you are getting a 10 volt output is always less than your input, and the feedback is working pretty much in the same way. It is called a shunt because here you are using a transistor in parallel. But here you don't need a current limiter. The current limiter is not required because you have got a resistor here. So if you are putting a very good resistor there, high rated, then you don't need a current limiter. That is an advantage of this system, because even the worst case what will happen is you may damage this resistor, then you can replace it. You are not burning the transistor. Usually you can get high wattage, high rated power wattage resistors. You can put one there so that you can limit your current using this resistor. So you don't need a current limiter. So no need of current limiter for the shunt regulator. So then now we learned step up, then step down shunt regulator, step down series regulator. So it is not possible to design step up using shunt or series geometries. But then you have several applications where you need to step up the voltage. So if you want to step up the voltage, so step up. So if you want to step up the voltage, means you got a 5 volt. So this is your input. If you want a 10 volt at the output, then you need to step up the voltage. Then we can think of how stepping up will work, because that's also an interesting concept. Like feedback, we are keeping the voltage constant, and current limiter, again that's a new concept. Again, stepping up the voltage also is a kind of an interesting way you can do. So as an engineer, somebody wants to step up the voltage. So what are the different options you would be thinking? Transformer is a good option, you can step up. But then can we step up DC voltage using transformer? Yeah. So if you are using, then again the question, if you got DC, how will you use a transformer to step up? Maybe you can make it pulse to your DC, and then you can step up. And maybe you can think of some less complex stuff. Yep. Sorry? Buck boost. But then buck boost, what is the, so we are going to study buck boost. But then my question is, what is the critical component will help you to step up the voltage in this shunt or, so I want to bring in some component. I will be adding to my series regulator or the shunt regulator that will help me to step up the voltage. So then which component you will bring in, excluding transformer? We already discussed about the transformer. Capacitor, capacitor, then how capacitor will step up? So somebody said inductor, but then my question is how inductor will help you? MOSFET will be helping you to switch, but inductor, I do agree, inductor. Then what property of the inductor is used? Voltage spike. Partially correct. Current. So I am going to draw you a simple circuit. In the simple circuit you will get some idea. So the simple circuit is, so you got a DC voltage. Then I am going to have a MOSFET. Then I am going to have a shunt. So this one is a Zener diode. So this is a Zener diode. From here I am going to connect an inductor as you said. So this is my load. So this may be some, say, 5 volt. And then here what I am going to do is, I am going to connect some pulses like this. So if I got this circuit, this is PMOS or NMOS? NMOS, because this arrow is inverted, this is the middle one, and then you have to look at the arrow here. So this is an NMOS, and then how this is going to step up the voltage? So that's what we are going to learn. So when you have an inductor, inductor got a property that is called back EMF, or inductor doesn't like change in the current. The capacitor doesn't like change in the voltage. Inductor doesn't like change in the current. So inductor is sensitive to di by dt. For the capacitor, dv by dt. So capacitor doesn't like change in the voltage. If there is a change in the voltage, what will happen is capacitor immediately will discharge to keep the voltage same. Inductor, if it is a constant current, then what is the inductor? What type of reactance, inductance will? If it is a constant DC, what will happen? It's like a short. But if the current is changing, inductor will oppose. So, for example, this is 5 volt, and then when this is 0 volt, maybe this is 1 volt. So during on time, so during this on time, so this is off and this is on. So during on time, what will happen is during on time, this MOSFET will be on. When this MOSFET will be on, then this 5 volt, then the current is flowing, and the 5 volt is coming this way, but then this is reverse biased. This is a Zener diode. So the Zener will be, the current will not flow this way because this is a reverse biased. So the current has to flow through the inductor, and then it will come to this point. Depending upon the load, some can go to the load, some will be going through this capacitor and then coming to the ground. So this is a path. You know what I meant? So if that is a path, that is the on stage. So the on stage charging. So on stage means then I'll be drawing the charging, something like that. So this is coming to the ground. Then whenever there is a kind of a charging, then whenever there something is charging, even a capacitor is charging or inductor is charging, so you have to keep one thing, the loop should be closed. There is no open-ended charging. So how the loop will be closed? Because this is coming, this ground is connected to this ground, so that your charging will be like this. You know, this loop is completed, and then so that this is going through the capacitor, and then so this will become positive, this will become negative because this is type positive voltage, and then that is a charging phase. So this will happen. Then next, when it is off, when this is off means your transistor is going to be off. When the transistor is going to be off means your current is changing. When the current is changing, inductor doesn't like change in the current. Then so what inductor will do is, then it will oppose the current flowing. Then what inductor will do? So then this polarity will become negative, this polarity will become positive, it will become reverse, the polarity become reverse, and then it will again discharge the current, the inductor. And then when the inductor is discharging, see off state also you are getting some voltage. So that's how you are getting, inductor is using as a charge bank, and then that is discharging. So that's how it is working. So when you have a switching mode, so this is the basic principle of a switching mode power supply. So I'll get the slide working, and then I got some neat diagram. So this is the basic principle of a switching mode power supply. So from here what you have to understand is, when you have an inductor, initially when you are charging, inductor may this become positive, this become negative, but when you stop charging, here the voltage is changing, then the inductor will reverse the polarity. This will become negative, this will become positive, because inductor wants to oppose the change in the current, and then it will discharge it. So that's how we are getting a stepping up operation, more voltage or more current, and hence more voltage. Yeah, so I will show you some good diagram. So from this what I am showing is the inductor will reverse the polarity. Okay, so I am going to show you some neat diagram so that you will understand how this is charging, how this voltage is going to increase. Yeah, we will take maybe 5 minutes break and then we will continue because anyway we will be having the lectures until 5:15.
I've got an interview on Wednesday for an internship, and I require 2 references. I've got one from an old boss, but I need a second. I was wondering if you'd be able to fill
Yeah,
it.
yeah, that's fine. Yeah, you please give me. So I have to fill in.
Yeah.
Yeah, yes, maybe after lecture
Yeah,
I'll
sure.
fill in. Yeah, yeah.
Okay.
And I'll give you them.
Yeah, because it's a few pages. It might take you 5
When do you need
minutes
it?
or
Then
so. Wednesday.
give me.
Yeah.
I will bring it tomorrow
Yeah, to me.
because I have to write it carefully.
Thank you very
Okay,
much.
thank you.
I want to ask you, is this voltage, when on the voltage equals to the reverse voltage for the cylinder diode? And so when L charge, C discharge, when L discharge,
No. So L is storing the first phase means this is charging like this.
yeah,
Okay.
yeah,
And then when this is off means what will happen is the polarity will, because in this mode anyway it can't discharge.
yeah,
And then when the charge is decreasing here, when you are turning off,
yeah.
this will reverse the polarity, the inductor. This will become negative, this will become positive.
Oh, okay.
And then again it will discharge through this way. So that in both the cycle you are getting current in one direction.
Oh, okay.
Otherwise, you get positive and negative.
Yeah, yeah, yeah. Okay.
Okay.
And I also want to ask for today's workshop, do we do the software?
No, software we will not do because the board, somebody should solder.
Oh, okay. So today's workshop still practice?
Yeah, that's practice. Yeah.
Okay. Thanks.
So after 1 week of the examining week, we still have one section, and during that time we can do the presentation. Right?
Yeah. So I'll be posting the date soon. Not today. Today I will announce. These are the arrangements. But
And here, I want to ask you.
yeah. So sorry, I couldn't because I was in the capstone exam today. So that's the reason I couldn't see you in the morning. No, in the afternoon. Because you said you can't come at 11.
No, I cannot
Yeah,
because I have the workshop, control workshop at that time.
Yeah, but then we can meet because this week I am very busy with capstone exam.
Oh, come on.
Then maybe we can meet. How about I'll write to you maybe Wednesday or something. Wednesday.
Wednesday.
Yeah.
Okay.
You please send me your calendar for Wednesday.
You can have a look just now here. When are you available?
Yeah, we can look.
Wednesday. Because I have some idea about
Wednesday 3, please.
3 o'clock.
3 o'clock.
Okay.
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 Wednesday 3. Okay.
Maybe mark it down, sir. We mark it down.
No.
Because the last time I wait for you half an hour.
No. So because if I am in the meeting, sorry for that. Because then what will happen is I can't come out.
Okay.
Yeah, that's the reason. Yeah, I think
Okay,
this 3 is fine. Yeah.
And here, I think that the basic principle is because we set a trigger, right? As long as the trigger and the signal going through comparator, it has a true, right? And then the CPLD send the clock signal to the ADC, and then it capturing the data, right? And then it capturing the data. But what I don't know is they capturing the data here. Is it when the trigger or false trigger is on, it capturing the data from to here, and then the MCU.
No. When the trigger is there, then the ADC starts sampling.
Okay.
The buffer will be on.
Okay.
Enabled, so that will be sampling and storing in the RAM.
What I don't know is if the RAM is not on, is it the data which you made here?
No, it will not stay here. Because when you disable this one,
Okay.
when you want to read it, what
Okay.
you do is you disable this buffer.
Okay.
When you disable the buffer, ADC is still sampling, but then it is coming to the input and lost.
And lost.
Yeah.
Okay, so if I want to read some data,
You have to read from the RAM.
I read from the RAM.
Yeah. The buffer is only kind of an opening. You are putting a buffer, digital buffer.
Okay.
So this buffer is just for when you are reading, you want to make sure that the data is not coming. Because if when you are reading, when the data is coming, that also is coming through.
Okay, for
So
example, if I force trigger, for example, right? So the clock is on, so this one it go to here, right? This one go to here. The data from the go to the ADC and the ADC go to the RAM.
Yeah. ADC, it was a buffer, it was to RAM. It will store in the RAM.
You store
Yeah,
in the RAM.
yeah. When you read, when it comes to display,
But what is the use of the RAM read?
yeah, because RAM
Here.
read will enable, because RAM read is high, then the buffer is transmitting the data. When you are displaying on it, then it is reading from the RAM. When it is reading from the RAM, you will disable the buffer using this one. Otherwise, it will be coming in parallel.
So
Because it's both the same lines are used here.
So I say the principle. You tell me that it's correct or not. The trigger or false trigger is on, right? And then the clock is on as long as the RAM read is on. So the ADC buffer and then the RAM.
RAM.
Here, right? And
When you want to display it, you
when I
will
want to
disable this one.
display, I disable a RAM off.
Yep.
This one.
This will be disabling here, so no
Okay.
data will come through, and then you are reading from the RAM.
I read it from the RAM.
Yeah. And then display it. Then during time, what happens is you are losing the data actually here. The ADC
But I see in the code that it is a procedure that this one read it here, and then here it read it here.
read it. Yeah. Then
It
again,
happened at the same time.
almost so it's like
Almost at the same time.
you are reading
It's one by one.
So this is storing, reading,
Storing,
then storing, reading. Yeah, you are losing a little bit.
Yeah.
Because you are doing fast. I'll check it. Yeah.
Do I have time to
Yeah.
ask questions?
Which one related to?
Just the circuit protector.
Yeah.
So you explain without incorporating the feedback here. So what if I incorporate the explanation? So if I short circuit this will be grounded.
Yeah.
This will be 0, but the difference, the error voltage will be definitely more than 0.7. So how does that explain the current limiting stuff? Because
So
you
when-
explain using the base current has been drawn out by this ICs, right? But if this is 0, that means your error voltage will be definitely more than 0.7. That means your VB here is also
No, but then this will not be 0 because you got this transistor.
yeah.
Some current is coming and then it is flowing through here.
But if I short it, shouldn't it go through all the way through the
Yeah. So this, if you are shorting, it will go through this one.
yeah.
And then what will happen is then you can this will then the error voltage will be very high, but still that will be pumped through this transistor. It will not go here.
Even that means how
then it will remain 0.7. 0.7.
So is this on or off? Because VB is greater than 0.7,
Yeah.
but there's no IB current.
I mean,
That's how it's on or off.
So depending upon which transistor you are going to put it here, you know what I mean? Yeah, that will decide that one.
So it suffices to explain without using this point.
Yeah. So we will start switching power supplies. So when it comes to switching power supplies, so we already started why we need switching. So the switching means then you can step up or step down. So in the switching mode power supply, there are two types of switching mode power supplies. One is non-isolating, another one is isolating. So non-isolating means it could be buck boost or buck boost. So these are the non-isolating. Isolating means flyback, forward, half bridge, full bridge. So what do you mean by isolating? Isolating, non-isolating means if you are using a transformer, you are isolating your input from the output. So if you are isolating your input from the output, it is called isolating. If you are not isolating input from the output, it is called non-isolating. Because some of you asked a question about the inductor. See, that's the reason I included this slide. An inductor is a passive element that stores